recorder, please don't stop the recording. Clear? And the last one is queues. Clear? All these 5 components will contain 20 marks. Clear? So other than this, you will have CIAs. CA1 10 mark and 2 10 marks and CA3 10 marks. Totally 30 marks. Okay, for your continuous internal assessment. So you'll have your internal markers 50 marks. Okay, the rest of the 50 marks you will get from your external examination. Okay, final exam. For final exam you will have 50 marks. Okay, you'll be writing 100 mark. That mark will be converted into a 50 mark. Okay, and that will be added in with your internal marks, and you will get your grade for your subject. Okay, formative assessment. So these components we call it as formative assessment: writing skills, problem solving, group assignment, simulation, quiz, and all. We call it as formative assessment. Okay, and the continuous internal assessment, okay, will have 30 marks. Okay, totally 50 marks, and end semester examination will have 50 marks. Okay, totally 100 marks for our subject. Any doubt in this? Okay, in your first model, that is your system modeling. System modeling. The first topic in your first model is basic elements of control system. Basic elements of control system. Okay, I am going to notate CS. C stands for control, S stands for system. Basic elements of control systems. And then the second topic is open loop and closed loop system. So open loop, I'll be noted as OL, open loop, and CL stands for closed loop systems. Closed loop systems. And then third topic is for finding a transfer function for electrical systems and mechanical systems. Okay, electrical and mechanical systems. So in that, both electrical and mechanical systems, we'll study about the translational and rotational system. Translational and rotational system. Okay, after this, the last topic in your first module is block diagram reduction using signal flow graph. Using a signal flow graph. Okay, these are the your first model. topics, subtopics available in your system modeling, module 1. Okay, basic elements of control system and open loop and closed loop system and transfer function for both electrical and mechanical. So in that mechanical and electrical, we'll study about the translational and rotational system. We'll derive the transfer function for both translational and rotational systems. And the last topic is block diagram reduction using signal flow graph. Okay, block diagram reduction is a separate topic and signal flow graph is an separate topic. Okay, but in our syllabus they have combined together. Okay, block diagram reduction using signal flow graph alone. Okay, we'll study separately what is block diagram reduction and what is signal flow graph. Then we'll study about the block diagram reduction technique using signal flow graph. Okay, before getting to the subject, I have a question that can I have an answer for what is system? What is system? In general, you say, I don't want any exact answer. In general, you just give the definition for what is system. In your BEEE Basics of Electrical and Electronics subject, you might have studied about what are networks, branches, isn't it? The same way you give me the answer for what is system.
So a combination of elements to perform a specific task is called a system. Sir.
Combination of elements to perform
A specific task. Sir.
Okay, nice answer. Very good.
A group of things working together.
A group of things working together. Bharat.
Yes, sir.
To perform a task. Okay. Nice answer. Any other answer other than this? Out of 27, I am getting only 2 answers.
Arrangement of things.
Okay, arrangement of things. Complete the sentence. Arrangement of things to do a particular function or particular task. Yes or no?
Yes, sir.
Okay, all your answers are right, but so other than this, all your answers are right. Let me give my point of view. Okay, when a number of elements or components are connected in a sequence to perform a specific function, okay, the group thus formed is called system. Am I right? When a number of elements or components are connected in a sequence to perform a specific task or specific function, okay, that we call it as a system, isn't it? Yes or no?
Yes, sir.
Elements are connected in a sequence to do particular function or task, we call it as system. And again come to the point that a control system. Okay, we can take an example of have you all studied about electrical machines 1? Yes or no?
Yes, sir.
Okay, fine. So we can take an example of a DC motor. Okay, what's your input for the motor? say any system. What are the input parameter for your motor? Either voltage or current? Yes or no? We'll be giving input parameter as voltage or current. So this is our input parameter. Okay. And what's your output from what you're getting the output from your motor in terms of speed, revolution per minute in RPM. Yes or no? So this is your output parameter, speed in revolution per minute, and these are input parameter. Now you can control the speed of a motor by varying either these two input parameter. Am I right? Yes or no? So here you can say your output parameter or the quantity of output is can be controlled or vary by the input quantity or input parameter. Okay, in such a system we call it as a control system. Clear? So in a system, when the output quantity is controlled by varying the input quantity, then the system is called control system. Clear? But the output quantity is control variable or response, and the input quantities we call it as in terms of input command or input signal. Input signal or input command. Okay, your output is I can say the output parameter as a response of a system. Okay, can you understand what is a system, what is a control system? Clear? So in this, for controlling any system, you can control the system by in a two way, or you can use two method. Either there may be a open loop system, okay, and closed loop system. Clear? So you can control your system either by open loop system, open loop control method, or closed loop control method. Clear? First, let's see what is a open loop system or open loop control method. Okay, for an open loop control system, we can take an example of consider you are driving a car. Okay, consider you are driving a car. Clear? So in that car, when you are driving, okay, you thought of driving a car at the speed of 50 kilometer per hour. Okay, what will you do? You want to maintain your car speed as 50 kilometer per hour. What will you do? What will you do? ஏன்னா தம்பி யாருக்குமே கார் ஓட்ட தெரியாதா? Hence Emmanuel.
Yes, sir.
Answer me. Assume that you are driving a car. Okay, you are thinking that you want to maintain your speed as 50 km per hour. What will you do? Simple. That's simple. You just give your pressure or force on the accelerator pedal. Okay, based on your requirement, isn't it? You'll apply a force on the accelerator pedal. Hence, am I right, Hence?
Yes, sir. Yes, sir.
Okay, what's your input here?
Pressure.
Yes, exactly. Pressure or I can say force. Okay, input command signal is force. And force to the accelerator pedal. Okay, which in turn connected to your vehicle engine. Okay, when you are giving pressure on the accelerator pedal, what will be the rate of fuel flow? Okay, this term we can say that it is a rate of fuel flow and to the engine of the vehicle, and you will get your desired speed as an controlled or variable output. Okay, output or response. Am I right? So your input for the system is force on the accelerator pedal. Okay, based on the force on the accelerator pedal, your rate of fuel flow going to be vary to the engine. Okay, based on the command given to the engine, the speed of the vehicle is going to be vary. You will get the variable response or variable speed or a constant speed based on your input. Am I right? Clear. So these were the best example for your open loop system. In the same way, let's see the closed loop system. Closed loop system. Clear. While driving a car, okay, you are not going to maintain, you are not going to concentrate only on the speed of the vehicle. Clear. What are the scenario or context you have to consider when you are driving a car? The level of road, yes, traffic signal. Am I right? எது எப்படி இருந்தாலும் நீங்க 50 கிலோமீட்டர்ல டிரைவ் பண்ணி போயிடுவீங்களா? Jagan, number 53. K. Jagan.
Sir.
Tell me, ma. When you're driving a car, if you want to maintain your car speed as 120 kilometer per hour, what are the parameters you will be consider?
Sir, road adjustment, sir. And
Okay.
opposite vehicles.
Yes.
Before vehicles also we have to see, sir. We have to see the mirror, side mirror.
Side mirrors. And then?
Then we have to control the car, sir.
Very nice answer. Okay, the same open loop system I am to consider the accelerator or engine to the speed. Okay, the entire thing I'm going to be say it is a open loop system. Clear? For the same input, you will get desired speed. Clear? This call it as a desired speed as an output parameter or output response. Clear? So your input are force. Clear? Where you are going to compare your speed, the speedometer which is available on your dashboard. Speedometer. Clear? So here you will see visually by visually you will see, okay, at which speed you are running. Clear? Say for example, your desired output is 120 kilometer per hour. Okay, you are thinking that okay you need to run your car for 120 kilometer per hour. Clear? For ensure to get 120 kilometer per hour, you'll compare your, this is actual speed, can say actual speed, the speedometer which is available in your car dashboard. This is your actual speed. Okay, say for example your speedometer is showing that it is 70 kilometer per hour. Okay, now your driver will check your speedometer whether our car is running by 120 kilometer per hour or not. Clear? If it is a 70 kilometer per hour, clear, what will your driver do? Will be vary the pressure or force on the accelerator pedal. Am I right? Yes or no? So meanwhile, the driver will check. So as Jagan say, the side mirror or behind the car and the traffic control. Clear? The level of the road. Okay, all these parameters will be considered. Clear? When the driver compare the actual speed with the reference speed, clear, the driver can achieve the desired speed from the car. Okay, this is a good example for closed loop control system. Clear? In a closed loop control system, if I draw a block diagram for exact block diagram for closed loop control system, okay, I'll have a comparator here to compare actual and reference speed of the car. Okay, and to the controller, this is our controller. Okay, here it is same our open loop system, our desired output. For input, I am going to keep as R of t. The output is C of t. Clear? For the comparison, I'll have a feedback loop. This is our feedback system to the comparator. Okay. This block can be comparator or error detector. Error detector. So this is a positive response, and your feedback is going to be a negative or positive feedback system. That we will see what is positive and negative feedback system in a later on class. Clear? So this is what your exact block diagram for a closed loop system. The control system in which the output has an effect on the input quantity in order to maintain the desired output value, okay, that we call it as a closed loop system. Clear? The control system in which the output has an effect on the input quantity in order to maintain the desired output value, that we call it as a closed loop system. Okay, and for an open loop system, have you all drawn this? Have you all drawn this? Have you all drawn this bar? Okay, fine. For an open loop system, okay, same as that your closed loop system. I have an input parameter here and output response from a system. This is our R of t and this is my C of t. Clear? Any physical system which does not automatically correct the variation in an output, okay, that system we call it as open loop system. Clear? Or otherwise we can say the control system in which the output quantity has no effect on input quantity, okay, that we call it as open loop control system. Clear? Which means that our open loop system, the output is not fed back to the input for the correction. Okay, we don't have any feedback from your output to the input. Okay, these are the main difference between open loop and closed loop system. Okay, let's see what are all the advantages and disadvantages on open loop and closed loop system. So the advantage of open loop system, first one is open loop system is simple and economical because we don't have any external component or feedback component from our output to the input. Clear? That's why the open loop system are simple and economical. Simple and economical. Clear? By seeing the construction wise, the output or open loop system are easier to construct. Easier to construct. Clear? But the open loop system are stable one. Open loop system are stable one. Clear? And then our disadvantages in your open loop system is it is inaccurate and unreliable because the output is not corrected automatically. We don't have any feedback from our output to the input. There won't be any comparison between actual and reference signal. Okay, whatever the input you are giving to the system, based on your input, you will get some of the output from your system. Clear? We could not say that output is desired output or accurate output. Clear? That's why our open loop system is inaccurate and unreliable. Inaccurate and unreliable. And next one, the changes in the output due to the external disturbance, which are not corrected automatically because of we don't have any feedback in the open loop system. The disturbance or error are not corrected automatically. Yeah, so these are the advantage and disadvantages of a open loop system. And next one, let's see the advantage and disadvantage of a closed loop system. So can anyone say what are the advantages of a closed loop system? What are the advantages of closed loop system? Any one point? First, we shall start from the accuracy. Yes. So these are accurate. Clear, which is not affected by external disturbance or error. Clear. We have no noisy in our a closed loop system. Okay, and it will make the system more reliable, or more stable. Okay, and then even it is a closed loop system, we also have disadvantages in a closed loop system. Okay, so the designing of a system is complex and costlier. Okay, for a closed loop system, the overall gain of the system will be reduced due to feedback. Okay, gain is reduced due to feedback. Clear? And disadvantages, the fine tuning of gain will take more time. Okay, fine tuning of gain will take more time. Clear? So these are the advantage and disadvantages of closed loop and open loop system. Yeah, we can have so many examples for the control system. Okay, temperature control system. For controlling the temperature, we can have both open loop and closed loop system, and traffic control system, numeric control system. Yeah. and position control of certain motors like servo motor, stepper motor. Okay.